Hey everybody, this is Larry. This is me going over Q3 of the weekly contest 451, maximum profit from trading stocks with discounts. Hit the like button, subscribe button, join my Discord, let me know what you think about this one. So yeah, this one was a very annoying problem, only because there's a lot of weird optimizations that the problem expects you to make. If n is like 100, then this is pretty much easier. And if you watch the video, you'll see that I got most of it pretty quickly. I had to do some optimization at the end. We'll talk about that for sure, but I just want to get you into the idea. The first thing to notice is that this is a tree, right? There's n nodes, there are n minus 1 edges, so it's a tree. And then the second thing is, of course, that the numbers are kind of small, and it's 160, budget is 160, and each thingy could be 50. So that immediately, honestly, if you look at the video, I immediately knew rough idea of what I wanted to do. Maybe not quite exactly, but I did, right? The idea here is just dynamic programming on a tree. Some more experienced people might ask about the star graph, but the thing is that this tree is rooted, and as a result, everything only happens in one direction. So everything happens in a way, not even DAG, but just that when you cache, if you want to think about caching or memorization, it always happens in one direction. You never go the other way because it is rooted, right? So that's the key thing about this one if you're curious about why dynamic programmer tree works. And then there are probably a lot of ways you can think about this one. I'll just show you my code real quick and just go through the states, right? But yeah. So okay, so the two I have two distinct functions that cause each other. We'll go over why in a now. But yeah. But first of all, we do construct the adjacency list. We convert the u and the v to -1, right? Oh, sorry. We subtract 1 to convert it to 0 index. Yeah. Otherwise, then here we kick it off. We create a cache, but otherwise we kick it off by saying that we node the parent, whether the parent bought and the budget left, and these are just the initial parameters. And here, this is given a node, consider whether we buy it or not, and we'll go over the go children next, right? It just processed the children, so we'll go over the code part, but you can just know that there's a function that goes over the children, right? So then there's buy, no buy, right? So if you no buy, that means that, well, we process the children for the node, the parent, and then I have this thing called C index, which is children index. So it just goes through the index of like, if you want to, I'm not going to draw it out because it's I have to set it up. But if you look at like if a node has like 5 children, then this is just this. You want to process the first one, which is the 0, and then 1, 2, 3, 4, 5, right? Kind of, or I guess it only goes up to 4, but in that order, right? So that's basically the idea about processing the children one in order. And the reason why you want to do that is just for caching reasons, which we'll go over in a sec. So the state is that, node is just, well, the node we're processing. Parent is the parent. And keeping in mind that, again, this is a rooted tree. So the parent is uniquely determined by the node. There's no other parent. It's always one direction. Always in one direction. I put emphasis on that. And if you don't know why, then that's fine. But like I said, the star graph is the tricky one. And then parent bought. I think this is pretty self-explanatory. In this problem, if your parent... I call it parent, but I guess your boss is this problem's lingo. If your boss bought the stock, you get it for the half price, right? So that's why this is important, or that's why we would like to know it. And then and then whether the parent bought, and then budget left is just how much budget we have left, right? Pretty straightforward so far, hopefully. And yeah, bear with me. And then if you know buy, then that means that, well, we just process the children with the same thing. We go to the first child. The parent did not buy, so it was the child, definition no buy. And then we didn't use any budget. Otherwise, we try to buy, and then the cost is going to be the present node divided by 2 if the parent bought, right? That's the parent discount, the boss discount. And then if we have the budget, then we spend it. And this should be straightforward to understand. This is the node, the parent, the children node didn't change. The parent, whether the parent bought, well, we bought, so the children's parent bought, and this will be true. Budget left, well, is the budget left minus the cost, and then this is the profit, right? The future node minus the cost, because this is how much we could sell it for. Keeping in mind that technically speaking, this can be negative. It can be negative if it gives you a discount big enough for your children, for example. So you have to be a little bit careful and not prematurely optimizing that one away, because that's an incorrect optimization, right? Okay. So then that's basically for processing the node. And now we have to process the children. And as I said, the reason why we have to do that with C-index and everything else is the same. C-index gives us the children that we are using it for. Well, we are processing or considering, if you will, right? And the reason why this works is just because, because you can imagine that we do a for loop. Well, the reason why is because we want the budget to carry over between the children, right? So we have to say, so like say you have $100 and you have 5 children. Well, how much you spend on the first branch, not just your children, but their children, etc. How much you spend on that tree, that branch of the tree, matters, right? So maybe that like we want to give 80 to the first child and their children, and like 10 to the third child or something, right? And because of that, you can't just do a for loop because you have to do like, I mean, you can't just do a for loop on the children because you have to basically iterate every possibility, every amount that you can give each child. And that's really the reason for this one. And then basically we have this thing where if v is equal to parent, well, then we just skip this child. That's basically what this is saying. And you could think of this as if you have a for loop. Maybe I should have saved that code, but if you watch the live portion, you'll see me do it. If you have a for loop, then this is just, if it's v is equal to parent, you just kind of ignore it, right? Because you can't go back up, right? And you don't want to go back up. And so maybe this is not a child, so I put child in quotes. Otherwise, we set best is equal to negative infinity. We go, okay. We give this child B budget, and the rest, well, budget left minus B, right? That's basically the idea, right? Here we want to process this node with the parent bought. I mean, this is just passed in because we have the same thing, right? So whether the parent bought, and then B is the budget for that sub-branch, sub-tree, right? And then now we want to process the other children, so then we just do C index plus 1. And the base case is that when we run out of children, we just go to 0, return 0, and that's it. Yeah. And that's it. That is a way, I mean, I don't know if I've gone too fast, too slow. Let me know in the questions if you have specific questions. Of course, just want to remind you that I don't understand. It's not a question. It's just a statement, and I can't really help you there. But in any case, that's basically the idea. And honestly, I thought this was not super bad. I don't remember my timing on it, but I think I got this relatively quickly. But after this, unfortunately, this times out, and I did not. Well, I did a lot of optimizations you can make, right? So I didn't know which one would be the right one. And we kind of look at, I gave it a little bit of a try. And this is the thing, right? Is that my accepted answer has the same complexity as this submission. It's just that I made enough optimization that it runs a little bit faster, just enough faster. I mean, okay, maybe it's like twice as fast or something like that. But even then, like, it's the same complexity with basically very straightforward recursion. So it's not like I'm doing anything too funky. If you look at this, there's no easy way to optimize. There are hard ways to optimize, and which I do, but no easy way, right? But we'll go over the complexity real quick since we brought it up. Keeping in mind that, okay, so again, I said parent is uniquely determined by node, so we could ignore this. Node goes from, there's 160 nodes. Budget is equal to 160, I think, and parent bought is going to be binary, right? So that means that number of states, number of inputs is equal to, I don't know, 160, times 160 times 2, which I will use a calculator to let you know, right? but this is going to be good enough. It's like 51K, right? And this is a tick, no tick, right? Pretty straightforward. So this is all one. This should be fast enough, right? So this one also should be the same, right? Because, okay, so you have node and C index. So this actually uniquely determines another node, right? So that means that this only has 160 differences, right? You can kind of figure that because the X children of node is just a V, right? And there's only 160 unique nodes. So that means that in total, node and C index will only give you 160 unique things. Parent, as I said, parent depends on node. So that also just doesn't add to it at all. I mean, maybe it's minor, just like storing the value. Parent board is 2. Budget left is 160, right? So again, the number of inputs is 160 times 160 times 2. However, the difference is that each input takes all of 160 time or something like this, right? Because there's this for loop on the budget. So then now this is going to be this times, and it becomes like 8.2 million, right? And of course, not all of this is possible because you can, like maybe use some budget. Actually, I guess maybe for this problem, actually, maybe I'm lying. All of this is possible. So 8.2 million maybe is just slightly on the too high side, right? And that's it. But yeah, but what optimization can we make? It took me a long time to get it, and oh yeah, I forgot to bring that. But yeah, you can see that I tried a lot. I can try converting to Java. Maybe I could have done a cleaner conversion to Java, but it just feels a little bit weird. But it turns out that that's the idea anyway, so I don't know. But yeah, and then I kind of did Q4, and I came back, and yeah, and then eventually I did get it, and we'll go with that solution now. And the idea here is just, I don't know, is just instead of having budget left being an input, I just say, okay, just give me an array of length budget that contains all the budget, right? So basically now instead we have node goes up to 160, parent it's 0 because it depends on node, and then parent board is going to be 160, right? Oh, sorry, parent 2 is 2, right? And the idea here is that returns an array f where f sub I is equal to if we spend $, what is the max profit, right? So that's basically what this does. But if you just do the complexity, it's the same thing, right? Because you have inputs is equal to 160 times 2, but now each input has a loop of 160, so it's again 160 times 160 times 2, right? So this is exactly the same as this, because this one is O of 1, right? So each input is O of 1. And the reason, and you may ask, well, if this is the same, why is this faster? Well, actually, let me finish doing this part first, right? So again, here, node and C index uniquely determines another node, so this is only 160. Maybe I should go over the code, and I'll go over the code real quick, but I just want to do a complexity analysis first. Parent depends on node, right, as we already talked about. Parent board is equal to 2, true or false, and then now we have 160 times 2, so this is inputs, number of inputs. Each input takes, as you can see, budget times budget, so it's equal to 100 square. Not quite because of the subtraction, but even if you do 100 square, it's fine. So then now total is going to be just 100 times 100, 160 times 160 times 160 times 2, which is exactly the same, right? 8.2 million. So why? So you may ask yourself, why is this faster? The TLDR is that in Python, every function call does have overhead, and I guess in this case, if you kind of take away 160, this is, or I guess going over here, right? So these are the number of inputs. That means that, yeah, we make a lot of function calls in this B loop, right? And as a result, maybe we're doing even 1 million function calls or something. I don't know, right? If that's the case, then yeah, we're doing millions of extra function calls, and they do add up. Of course, this is kind of a thing that problem writers should know about, and otherwise it's just like a huge disadvantage for Python, right? But instead, so what we did is that we used an array, and with an array, then we are able to do this much faster because we don't use the function calls, even though this is exactly the same, right? Okay. So let's go over the code real quick. I mean, the by, no by is the same, right? The idea is that you only kind of, I mean, the transitions are exactly the same, of course. This is the transition, and this is the transition, right? Same as here, right? Here and here. The only difference is that now, we're given this, if we spend $i, we have the profit f sub I. F sub I is the max profit, let's write it that way, right? Then now here, so if you have no by, then f is just literally this. Maybe we can make a, do I need to make a copy of this? I think maybe this is actually a little bit sketch. I think we got a little bit lucky in that there is a thing, because I think actually I messed up here. I mean, it still works. And now this should be slightly slower, but that's fine because it's actually more correct. But we reuse, we reuse things. But the thing is that we only reuse from the children, so maybe that's why it works. Because okay, actually, but that's still pretty bad. I only noticed it now, right? But the idea is that okay, now then you combine it in a new array. And if you do it in a new array, then so this is no by, and then by is that if you have the cost, so that means that for each k in the previous budget, if you add it to cost, then well, one is that you don't change, but the other is that you have this piece of k, which is the budget for if the parent bought. So this gives you the entire range of budgets and the profits, and then we just do the math through k and k plus cost. So it's just matching the numbers up. And then this one is the same idea for each children. I don't change this at all, so I'm not going to go over this part in that much detail. But I just call things left and right when I combine things. I don't know, maybe I need to name things. But this one is for this current node, right? This is what I realized that for this one I didn't because I did do a little rename to make it easier to read. But whoops. But this one on the left we go, okay, we process this for this one node, for this re node. Otherwise this is for the rest of the children, right? So this is for this child, and this is for the rest of the children. And then we just kind of merge them, right? We do a loop on the budget on the left side, we do a loop on the budget on the right side, and then we just combine them. And this should be pretty straightforward, hopefully, because that's the total budget spent, and that's the total benefit, right? And then we just kind of F max over it. And that's it. The complexity is the same, but and that took me forever to do, and that's it. Let me know what you think. This is the top. This is setting up the adjacency list. This is the processing of the existing node, and this is processing of the children. But honestly, I think this is a beautiful problem if it weren't for the fact that Leetcode ruined it for Python people. So I don't know. And also, you wonder why I don't do these contests live anymore. Problems like this is why, because they just are kind of crap to play with. Even when you have a good problem, they just ruin it by not knowing what the constraints should be. And and that's it. That's all I have for this one. Let me know what you think. Thanks for watching. And you can watch me try to solve this during the contest now. Okay. I was like, that's too easy to... okay, we have 2 hearts. A 5-pointer and a 4-pointer? Is that right? That's kind of weird for 2 hearts. And also Q4 is fewer points, so let me try that first, I guess. No, actually, let's just try it in order. All right. Okay, you have integer n represent the number of employees in a company. 1 to n. Employee 1 is the CEO. Okay, 1 to n. Okay, present and future, where present is the current price the employee can buy a stock today. Future, okay. Very confusing so far. 2D UV means that U is the direct boss of V. Okay, I mean that's fine. You have to think your budget total fund for investment. However, if the direct boss purchased own stock, then at half the price. What is going on with this problem? Okay, there's just a lot of things going on. Return the maximum profit that can be achieved without exceeding the given budget. Okay. So basically, you only buy if the future is, yeah, you buy each stock at most once. Huh? Oh, okay. But does that mean like, what does you can buy it once mean? Like each employee can only buy it once, or they buy it at the same time or something? Fuse D. Oh, I was gonna say Fuse DP, but N is 160 is a little bit awkward for that. Also, budget is 160, so that is weird. But okay, but we have a tree of the hierarchy. All right, let's set up the tree first. Oops. Okay. I also want to convert it to 0 based. Okay. Okay, so budget is going to be part of the recursion, right? And is that it? I guess so, right? Then it's just recurse down. It's not that bad, right? Maybe. So then we have the current node. We have whether the parent bought. No, the parent itself and also parent bought. And then the budget left, right? Something like that. Is that good enough? Present and future seems weird. Why is that only 50? I guess it doesn't, because the budget's 160 anyway, so maybe that doesn't matter. Alright, fine. But I think this is it, right? So then now is just buy, no buy, right? So yeah, best is you go to negative infinity just to make it easy. Is it negative infinity? Maybe it's infinity, I don't know. Or maybe 0, sorry, not negative infinity. Okay, so then we buy, no buy. Buy is we, okay, so, okay, let's do the no buy first, because that's easier, maybe. For we in E sub node, then we go we node force budget left is going to be the same because we didn't buy. So then we want to add up all the gains we have from here, and then yeah, so this total is going to be no buy, right? Yeah. And then buy, it's going to be let's see, maybe I could roll it up, I don't know. Okay, so then buy, what does buy look like? Oh, that is tricky, isn't it? Huh? But the thing is, you can't pass in budget like this. I see. You can't pass in budget like this because your left branch and your right branch might both use. So what you want is actually just give them a budget left. Right? How do I structure it? Huh, yeah, that's not right. I can't do it this way. Unless there's some weird thing. I guess this part plays into it. Maybe. No, I mean, it's still just part of the budget. How do I do the budget then? I mean, okay. But is that math good enough? Okay, I think I get it, but it's still tricky. So node is 160, parent doesn't matter, parent board is 2, and budget left is 160. So then now we just have to add in another one, which is the number of the child, right? So child index, say, okay, right? Yeah, that's not right. I mean, okay, that's why they want to do by first, I suppose. Okay. Then the end. Okay, go.cache clear. Always remember. We want all is equal to go. We want node 0, no parent. Child index is just 0, for example. Parent board, force, and budget left is just going to be budget. And then we just return out. Okay, so that's good. And then now what we want is actually not this. We want, okay. So if C index is greater than or equal to length of E node, then we just, what would that? Then we just return 0, right? We made no profit, right? So it's fine. Otherwise, then instead of this, we have V is equal to E node of C index. And then we just buy no buy, right? I guess we have to figure out if we're buying no buying this thing. Okay, so okay, I mean we can vote in the same function, but I think we just need a different function, right? So here we want go to, say no, and maybe this is go to anyway. So then now we don't do the C index thing, and then now, and parent board only matters for this anyway, where it does not matter for this. Nope. Okay. Okay. So then now we want to say, okay, buy no buy, right? So buy we have I need to name these things better, but it is what it is. Got node, we got parent, we got, so C index is going to just be 0 for the first one, and then we have, well, everything else we want to give to this thing. Okay, so buy is going to be if budget. All right, let's just do no buy first, Larry. Okay, so no buy, we do this. Is that good? Yeah, we didn't buy any. I guess we do need parent board actually. So then this is going to be force, budget left, right? Okay, and then buy is going to be go, and this is only if budget left is greater than or equal to present subnode, And technically, I don't know. I mean, maybe we should double. No, you may want to buy it for a loss if it gives you a profit in the beginning with your children. So maybe that's why. So okay, so actually we still want to do that as long as we could afford it. Then it's going to be go node parent, same thing. 0 true budget left minus present of node. So that's your budget. And then the profit is going to be just plus future sub node minus present sub node, right? So that's the profit. Okay, and then return best. I think this is fine. And then now, even the ordering is maybe a little bit funky, because I think maybe we should, but whatever. Okay, so then now, yeah, we just want to consider this node, right? Okay, if this is it's done. Otherwise, we have to brute force how much we have to brute force how much budget to give this branch, right? I think that's the idea. I think that's why I wrote it in this weird way. Budget, right? Okay, then best. Basically, then now it means that we want to make the decision with this. Oops. Also, if parent, if e node of c index, okay, so let's say v is equal to if v is equal to parent, then we also just skip to the next one. So if that is that, then we just return go node, we go node parent, c index plus 1, parent board, budget left. Otherwise, we just calculate how much budget to give it, right? Which is going to be, okay, so then this is v node zero parent board. So yeah, this goes up to the parent board. Budget left. So B is the budget that we're giving it. B is the budget we're giving it. And then plus go of node parent c index plus 1, same things, except for budget left minus b, right? I think that's it. I think actually technically we should write this and the go to the crash clear. I feel like this is roughly right, but maybe not. Okay, go to. Okay, line 37. So go is node parents. Oh no, this is go to. No, this is go node parent c index budget, and this is go to, which does not have the index. All right. I messed up something, but that's fine. Because I didn't do the parent thing. I didn't use the, so for this one we buy. So the cost is equal to future node. If parent bought, then cost divided by 2. Is it 4 or okay, 4. So okay, so then now this is just, oh whoops, nope. Also, I got the wrong one. That's not future. You want present. Why would I? Oh, and also now I messed up here too, right? Because now it's cheaper to buy. Okay. Okay. 5, 4, 10, 8. 5, 4, 10, 12. Close, but not quite. Cash. Okay, just want to make sure that I have that right. Oh, because the parent continues, is that right? But okay, but why would I have? How much time do I have left? An hour and 9 minutes. Okay. A lot of people got it in 1 minute. That sounds totally legitimate. Okay. So yeah, I mean, everyone just buys, right? 5, 1, 1, so 12. Okay. Am I wrong on this one? 0. Oh, this is cost. Not okay. I did it in one place, but I didn't do it in other. Okay, so 5, 4, 10, 12. Let me double check. Looks okay. Would I like to test this? Probably, but let's YOLO submit. If it times out, it times out. But if I could have tested a little bit, but I think that's fine. I don't know if it's because complexity should be okay, but maybe Leetcode is just silly. Which it looks like it will be. That's unfortunate, actually. Yeah. I mean, okay. Well, let's see. Actually, maybe I don't know if it's me yet or not. I mean, this one takes 1 second, which is maybe fine. I don't know. It's hard to tell whether. Yeah. I mean, this seems like it's a max case, so if it doesn't work, I honestly will blame Leetcode on this one. I mean, it is what it is. Because this is pretty what is this? 160, 160. This is 160, 160. This is a little bit iffy, but and this is the only part of the loop. Can I do a little bit better on the loop? I don't know, to be honest. All right, let's see if I can ChatGPT this into another language. I don't know if this is good. This looks ridiculous, the code that they're generating. I don't know if I could do bottoms up easily. This is the only part that maybe is a little bit sketch. But like, can I do this in an easier way? I don't know. Did they tell you what this timeout is? Or like how close are we? I don't remember if this is like when it's live or not. I'm trying to go to C++. Compiler error. I'll go to. That sounds right. I didn't really look at it. It should be auto anyway. I don't know how to do this on in C++ also. Maybe I should just convert to Java. I forget how to do it. But I mean, it's roughly right, but honestly, on the margins, I could see how it could be a little bit slow. And this page isn't even loading for some reason. Why is this not loading? Right, well. Just how, what the? This is very weird, but okay. Huh? What is it telling me? Oh, intent coming to list int. Okay, fine. Is that how they have it? It is not great translation actually, but I just want to see if it would even be fast enough. I mean, this is actually like faster, but it's still not super fast, right? Should I YOLO submit? Yeah, let's go. I wouldn't be surprised if it's wrong. If it times out, I'll also be a little bit sad, but I can't even get this page to load, so yeah, it's gonna time out. Oh, there's some more details. Okay, so but I don't know the more details for the other one because it doesn't even load anymore. Oh, so my Python one is actually even closer. So we only had 10 test cases away. I don't know. This is just really silly. I feel like every like 2 contests I have this. That's why I don't do Leetcode contests anymore. It's just that they don't. I don't know. I mean, the Java one probably could be optimized. It's either that or this. I don't know. And that's the other thing is that when you're uncertain, when you don't have trust, you don't even know if this is me or them anymore. Because this is just, it could be me, it could be them. It's hard to say. But yeah. Budget of 0 doesn't make sense. But maybe I could make this slightly more sensible. I don't know. Just faster. It's faster by a little bit, but like I guess I could do like if budget left is equal to 0, we return 0, right? Yeah, I don't think there's any controversy there. And in that case, then it doesn't really matter what's going on here. Also same here. Maybe we can just like. Huh, I was wrong apparently. Why is that? Because b is equal to 0, go to. Why is this changing? Is this wrong though to do? 5, 4, 10, 12, is it? Okay, this is much faster, but I don't know that this is right. Is it just like a querying thing, or it's so hard to test whether these optimizations will do it. Even though we got most of the problem correctly set up. Can I eliminate one thing? I don't know. I mean, this is pretty bare bones. This is the only time you actually buy. This loops the children for me. I don't know. I want to write this, but I feel like maybe it doesn't matter. Maybe that was just a random variant anyway. And I don't even know if 10% faster, it's not even 10% faster sometimes. So maybe it's just random and it doesn't do much. What can I otherwise optimize? This and this is going to be a little port. Well, there's a loop here. Maybe we can do something dumb, like does that make it enough? That would be stupid if it's true. Let's give it YOLO submit. Yeah, looks like it's still a little bit too slow. 780 of 790. But it is silly though. That's wrong answer. Huh. That is actually shocking. In fewer. Wasn't this right before? I don't get it. And they don't tell us the input. Okay, I guess this is the input bit. What? Is it because of this? Can cost be 0? No. Expected 82. I mean, this is the only thing that I added, so I guess I will remove it. But, wow, I can't believe I added something that was wrong. Okay, wow. But now removing those, this is much longer again, so I don't even know if why is that? How can you... Budget left is 0 to 0. Why? What changes about that problem? Why is that enough? Like, what if you don't have money? What can you do? Oh, you could still buy with no money if the parent is true. So okay, I see. So if budget left is equal to 0 and parent port is false, return 0. Is that happy enough for you? Okay, that just makes it slower for some reason. I guess some reason is that it's more if statement, but you know. Okay, and maybe we should just convert this to 0. So that the comparison maybe is a little bit cheaper. Not that much. And it feels like it's like a random number generator. I'm not confident about this. It is faster. So I'm going to YOLO submit just because I have no idea what else to do. Really? I mean, there's some optimizations that we can make here. But like they're very minor optimizations and you never know if there's enough, right? I think that's the problem. So this one we skip. Doesn't look like it's enough either. In fact, this is the same number. Yeah, I mean, that's the thing, right? Is that you can never test this because it takes 1.5 seconds for this, which is fine. But we don't know how many inputs they're going to give. I guess 800, but how many of them are expensive? Who knows? And this is just dumb. Like, we spent like 10, 15 minutes on not really solving the problem. I mean, unless I'm really off by a dimension, but at Leetcode, you never know to trust them, whether it's just us or whatever. I guess this is fine, but so, this part is the part that I want to figure out if I can. Yeah, I don't know. It's just 160, but I mean, the only thing is the C indexing. When do I give up? When do I give up? When your number is mostly right. I mean, the reason why the Java doesn't work is because it does all this like crazy key concatenation things. So that's, you know, like if we were more native Java, maybe that'll be fine, but I don't know if I want to spend time on it. Now I don't know what window I'm looking at. I think I lost my window. How much time do I have left? Okay, just we'll end it actually. I'm on the right contest, right? 53 minutes. So I spent like at least 15 minutes just working on this silly debugging. I guess I could do it here, but I don't know if that matters that much. But that's what I mean by optimizing, right? Like it'll be slightly faster, but still not fast enough. Because I have to do like 10 more test cases. Is this? This is a linked list, right? Is it? How many edges can we have? Is it a tree? It is a tree. That means that this C index should not be that big. It should be like 160. I guess 160 cube was always a little bit big. I thought maybe 160 cube is not that big, but actually now that I think about it, I don't know what I'm thinking. I mean, it's like 4 million. It's not small, but it's not big. I mean, it's not big, but it's not small either, is what I mean. Like, can I do this part a little bit smaller? Yes, by topological sort. No, but then you have to know whether its parent spent money, right? I mean, you couldn't still do topological sort, but how are you going to do it? Or how are you going to do this up? Can you propagate it back up in an easier way? It's just like you have this. Like if it was 100, then it would be, I guess, fast enough. Barely. But 160 is so weird. Can I eliminate some part of it? Is this a tree? It is a tree. So that's 160, 160, 160. How do you eliminate one part of it? I mean, 4 million should not be that bad, honestly. And like everything else is cheap, so it's maybe just a function and cache and all these things. I want to write my own cache. Is that what it's coming down to? right? Something like that, right? And then have to convert this to int, maybe. And then yeah. Would that be faster? One-time error though. Cache clear, okay, that's fair. Yeah, it's still kind of slow. I don't know if it's just me. Like, it's not drastic enough for me to be like, oh, that must be it. Nope. Said you went right though, the answer. We didn't even check the answer. Yeah, it looks right. But it's just not faster. Or at least not significantly faster. Why is that? The space is not the issue. And the lookup is not that bad. Because it's only 160, 160, right? So is it just like... Yeah, 1.2. The thing is that, like, it still doesn't tell me enough whether that's good enough. And that's kind of sad. And C indexes variables. I don't know how to generate that easily with this. I mean, I'm going to just YOLO submit because I don't have any idea. Is this a little bit faster? Can I write it bottom up? I don't know if I can write it bottom up easily. This is going to time out. All right, it's time to look at Q4, I suppose. And then just, yeah, same submission, right? Oh, one more actually. Okay, well, let's just stick that in there just in case that's a different thing. How long does it take? We'll just assume that, you know, yeah, 2.947, that's bad. Okay. Okay, I mean, we have 11 minutes left. Honestly, I don't know how to do this one. Can I think about a budget in a different way? It has to be profit, not returns. Okay. I'm stuck on this optimization. I have 10 minutes. And we're so close. I don't know if we're actually that close, honestly. But I'm curious about some optimization on Q4. What am I missing? Let me double check reading this budget. Total fun. I mean, it should be fast enough. Is it just like a Python thing? Did people sub in Python? Some people subbed in Python, even if it's ChatGPT's. Let me see, this possible. I don't know if there is a way to optimize this. No buy, and go for the yes buy. Okay. I mean, this part is fine. Oh, I don't know, but it's fast enough. There's this thing, right? Like if we... did I close the wrong window? I closed the wrong window. In the sense that I had test cases, right? So that's actually unfortunate. Okay, fine. Because I was using them to benchmark, but I mean, I don't care anymore. 7 minutes. I'm gonna get a wrong answer because I just want that to get a big case to benchmark. I mean, obviously this doesn't really count anyway, so maybe that's fine. Even though you shouldn't think like that, but I'm too lazy to go back to look for it. I should have better setup for this, but it is what it is. Yep. Yeah, so it took like 9 seconds or something. Yeah, 9 seconds this time. But okay. How do we want to optimize it? So let's say we don't have to, so let's say I don't know, let's say B is equal budget left divided by 2, just for science of is it fast enough? Okay, so without it this is blazing. So that means that I don't know if this is the reason, but maybe we can optimize some parts of this. 2.6. I mean, even within these testing, there's so much variance, right? I don't know. This just skips. What are numbers that are interesting here? But then if you have like this one where all the costs are 1, it doesn't even matter. Like I would think about some optimization where we can skip some numbers or something, but this should have been deduped here anyway, so I don't even know. I think this is pretty full though. Can I write this in a DP way, or like bottoms up, just to save enough of time to? Is it rerouting? No, I don't think so. I see. I think instead of budget left, we would calculate our best per thing, maybe? Okay. I mean, I don't know that this works, and I don't have time to implement it 4 minutes, but I'll try to do it afterwards. How would we consider it? So let's just consider it without a budget. But how is that different? So I think that's just implicit, right? And you just do recursive. Yeah, I don't know that that's different. Other than maybe slight efficiency in storage. This is very frustrating because I feel like we're so close. 780 out of 790 just means that Leetcode is just being silly. I think. Or at least, I don't know. Maybe there is a way you can get rid of this. I think that if we were able to get rid of this, or at least two numbers where that matters, then that would be a lot easier. Why do I have this? I think I just kind of did it for an example. Oh, that's why it's faster, because it was running smaller numbers. But I guess here we don't care about a parent. Oh no, we do care. This is where we care about a parent. This we don't care about a parent, but we use it to pass it in. Okay. Yeah, I mean, maybe it is easier if we just kind of... No, but I feel like we just calculate all the things at once. Oh, it is fewer function calls. Maybe that's it. I don't know, but that's just such a 28 seconds, so we're not finishing this. That's for sure. Because basically the idea is that instead of using budget left, or how would we write it? We go... Okay. Yeah, it's fine. We have enough of this to not work. I just double check that it's still correct, even if slow. Okay. And time is over, as you can see. But now what we want is, instead of budget left, this just returns all the things that it costs. Maybe how would that look like? Okay, so we don't buy, then we have, I don't know, just go no buy. So this would give us, I don't know, a table, right? Okay, so this we want. Okay, no budget left. Okay, no buy. This will give us all the possible budgets, right? So maybe, so it would have something like 0, maybe, right? And then buy, we have this thing. So then that means that the budget we use is going to be, okay, well, okay. And then now we have C, and then the budget we used. So the profit is going to be, so profit is equal to profit, and then instead of best, we just kind of okay. So then what am I trying to get this to return to? So this should return all the budgets, right? So that's going to look like this. With what does that look like? So basically all of the budget and profit, right? So then we want to add this thing to it, which is the budget is cost, this is the profit, right? So and maybe using a map is too confusing, I don't know. Not confusing, but maybe it is. To make copy, how do I do a copy on a map? Make copy of map. Is it just like dot copy? That's a shell copy. Copy dot declare. That's something that, oh, using the dict constructor. No, it creates a shadow copy. Okay, we'll just write something like for key in p values. Okay, so we have a best maybe is equal to say right, and then now we go, okay, F, so this is the budget, so P, so this is the budget used, so budget used plus cost is equal to min or max, sorry, max of what it used to be, or P of K plus future node minus cost, right? I don't even know if this is useful, to be honest. But these are the, okay, so that's kind of what we have here for this. And then now here, yeah, this will return this. otherwise return the next number. Okay, and then now we want to return all the budget stuff. Is this even an optimization that makes sense? Budget left doesn't even make sense. I don't even know if this is true. We don't need it. But then this thing is going to be big, so it's still going to be a loop. I think I'm being dumb. I think actually maybe we can do an array of budget instead. What would that look like? This is just too confusing. Okay, so this is going to be say 0 times budget plus 1. Okay, so then now, okay, P is going to be an array that is similar to this. And then now for I in range of budget, we may optimize it out later, but for now, I think this is fine. Or I guess let's make it K. So then now this is true, right? And then we return F. Okay, and now this is just going to be say 0 times budget plus 1. We don't do best anymore. And now what would that look like? Oh, then we consider best buy no buy, so that's this. So let's say naming things is hard. I just usually name it left and right, which is kind of terrible too actually, but okay, so you have this. Right is equal to this. Okay, then how do you merge? Is it a budget square thing? Oh, this is where you do a merge. I see. Because the idea then now is that it's like a prefix something on how I make a copy of it, and that's how you get rid of the factor. Because now you're getting because basically they both gives you budget and the best things, and then now so for I or B maybe in range of budget plus 1, then we use B in left, so that's just F. So that's just F of B. And then budget minus B in right? So then that means that B plus, that's not quite right. I mean, it matters, it's not a suffix thing, only because it matters what the sum of the costs are, right? So you need something like B left. Okay, so no, so I don't think I got rid of anything. If BL plus BR, right? Then now, I mean, maybe it is faster, but it's not because I improved the complexity. and then it's max of this. All right. Do I have? We have f max. I have. Okay. So we have an on-time error. Go to takes 3 positions. Oh, that's probably true. What line? I also need to fix a few things like here, so it's fine. Line 50. Oh, yep. Max of bar. Budget left is not defined. You mean bisect left line 38? It's probably true. I just didn't remove it. Budget left 25. How do I still have this? Oh, this is okay. I guess we don't need it anymore. Out of bounds, of course, because we didn't count the if k plus cost is less than budget. Okay, I mean it gives me the wrong answer, but it is twice as fast. And we print stuff, so it may be the printing issue. But am I confident that it's doing twice as fast, or is it just like being stupid? You know, like it's wrong, so it's doing a lot less work, so that's why it's twice as fast. But let's see. So it thinks that is 022. What does this look like again? Is it this one? So we have just looking for my code real quick. I mean, sound looks okay, but okay, so okay, so it's just 4. So why is it 2? So okay, so here it goes 2. It goes no. Oh, I forgot no by. That's why. Okay, that's fine actually. Actually, we just do f is equal to this, and that should be fine. And then the max is here anyway. Is this right? I don't know. Is it fast enough? Oh, I print too much. Well, if I get an excessive output something, output limit order, that means that either way we have to submit again unless it ACs in a lucky way. Oh, it does ACs in a lucky way. I don't know. Why is this? I mean, I think. Honestly, I'm not happy about it, right? Because I basically got it. It's just that it didn't, and this is whatever anyway. It's just that I had to optimize like a constant, and that constant just comes from it comes from the fact that we make too many function calls, but it doesn't actually like change the complexity. The complexity is the same, so it's just kind of crappy. Like 14 seconds. I don't know how much it is before, but I don't know. What a crappy problem. How do people do it? I mean, there's ChatGPT, so. I mean, I guess they did it kind of similar to the way that I did it. Well, now, but yeah, like this part, right? Like, actually, I guess my for loop could be a little bit tighter, but like what? No, I mean, well, this part would have. No, I mean it's fine. Like maybe this should have been minus BL plus 1, something like that. Maybe that'll be faster. But like I don't even care that much, right? Like that's not the thing that makes it. I mean, it is actually much faster, but and then like this, but you can minus the cost here, and you don't have to do this anymore, unless I did it wrong. But right, so there's some like, but it's just like a crappy thing, right? Because we didn't. Yeah, I mean, I don't know. Like I had it, but I just didn't do the right optimization, right? I think that's the thing. Like is, and I tried other optimizations, but you know, the code is sometimes a little bit silly. Yeah, I mean this actually is like quite a bit faster, but I mean this should have been right. Yeah, Alex is asking. Yeah. Um, yeah, I mean, I don't know. It's just like very silly. I think that's all. I mean, I fundamentally did not change much. I just kind of made it cache a list instead. And interestingly, someone on my Discord, which is why I was like looking, like earlier was maybe I'll give him some credit. His name being Segmentary was talking about caching different things on the indexes as a way to optimize things, and I was like, eh. And honestly, I also even like made fun. I didn't make fun of him, but I was just like, it's not that important. It doesn't really come up that much. And then next thing you know, literally on this problem, it comes up, and I was like, but part of this and why it's not interesting is because the reason why this works is because it's just all function calls. You're reducing the number of function calls, and also kind of you want to get into it like memory access and stuff like that, right? So it's basically the same. So instead of doing a full bottoms up, this kind of makes it like a little bit tighter, which very rarely you need to do. So I think this is just a failure of the problem writer in general. Yeah. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this contest, everything in between. Stay good, stay healthy, to get mental health. I'll see y'all later and take care. Bye-bye.